All right. So, oh, I didn't say it. Happy Tuesday. Happy Tuesday. Happy Tuesday. Hope you're having a good Tuesday so far. Technical difficulties finally fixed. Thank you for your help. Thank you for your patience. I appreciate it. Nobody was complaining. I think some of you are wishing that I'd have technical difficulties the entire period. Yeah, I know you kids. I know you guys. You guys like to have things like this happen. Or the other thing you guys do is you have teachers tell stories. Hey, mister, hey, miss, tell us a story. And then they tell a story, and then it takes up a whole big chunk of the class, and you're like, yes, we didn't do work. Oh, you slept? Somebody said I love sleep. It's too early for math. Oh, it's never too early for math. All right, so let's recap. What have we learned? We've learned what similar polygons are. Polygons that are the same, just different sizes, right? We learned that the two things, and this is the most important part, the two things that are true when figures are similar, all corresponding angles are congruent, right? Because if I change the angles, the shape changes. And all the sides are proportional. That means all the sides grow or shrink at the same rate, the same ratio, right? A rate is just a ratio. And what ratios are we looking at? We're looking at ratios between sides, right? Right? We're looking at ratios between sides. And ratios are written as fractions. So we have a top and a bottom to the fraction, numerator and denominator. So which one goes on top, which one goes on the bottom? Well, the order matters, right? When we're looking for this ratio, also known as the scale factor, you've seen that in real life. Scale factor. I actually was going to buy this this Michael Jordan model, right? This Michael Jordan model, that it's this model thing of Michael Jordan of his rookie year, and it's a 1 to 9 scale. It told me it's a 1 to 9 scale. Right? It's not life size. If it was 1 to 1, that means it's life size. It's 1 to 9, meaning 9 is the large, 1 is the small. And so that means it is not, Michael Jordan would be 9 times bigger than the figure, or the figure is 1/9. So if we look at large to small, it's 9 to 1. Michael Jordan is 9 times bigger than that. If I look from the figure to Michael Jordan, it's 1 to 9 from small to big. That means the figure is 1/9 the size of Michael Jordan. So it depends on what order you're looking at. And that's all you're doing, is you're making ratios of sides. Now, how do we know which sides are corresponding? Well, we have to look at the order, right? A, B, C, D, E, F. A matches with D because they're both first. B matches with E because they're both second. C matches with F because they're both third. So that's what we're doing. We talked about scale factor, finding that ratio, and then we talked about similarity statements, right? This little symbol right here is similar. And then the order tells us what matches. And so then what the advice I give you is to color code everything. That's the way I would do it, because first one's purple, second one's green, third one's orange. If you mark them all here, I can match the sides. Purple, green, oops. Purple, green, right? JK, PM. So I can match all the sides real easily just by looking at the colors. KL, MN, because it's green to orange. LJ, NP. So I can create those, and that's what we were doing. We were creating those, what angles are congruent and what sides are proportional. So we created proportions by doing which ratios equal each other, right? And how do we know what order to go in? The order that the problem gives it to us. This one was small to large. I think the next one was large to small. Always look at the problem. If you don't know which one do I put on top? Always look at the problem. So now we're going to use all this knowledge. We're going to use all this knowledge we learned to look at two similar figures and figure out what is the length. What is the length of a side? So what are we going to need to do that? We're going to need to set up a proportion. Okay? We're going to need to set up a proportion to do that. We're going to have to have one ratio equal another ratio. And one piece of that proportion is going to be missing. Okay? So let's see which one. Let's see what we have. So there's different ways to do this because they'll give you different information. So first thing I want to look at, this is the small. This is the large. Now remember I told you the order matters. The order matters. So let's see what we have here. If the figures below are similar, so they're telling you, yes, they are similar. So that means the sides are proportional. That means I can make a proportion. That means I can do this. with a scale factor of 2 to 3. Do you notice this? 2 to 3. Isn't that a smaller number? So that's the small. Isn't 3 a larger number? So that's the large. So we're doing a scale factor of 2 to 3. So guess what? That's one of my ratios, 2 to 3. My scale factor is 2/3, 2 to 3. That means that's the ratio. Remember, your scale factor is the ratio between the figures. That's what scale factor is. Go back over here. Scale factor is the ratio. I thought we wrote that here. It's the ratio between figures. Okay, that's what the scale factor is. It's just your ratio between the figures. Right, like my Michael Jordan example, 1 to 9 or 9 to 1. Okay, so once they give you the scale factor, they kind of did a lot of work for you. They gave you the ratio. Okay, and they're going from small to large. You notice this? If they're going from small to large. So I put 2 over 3. So now, what do you see in the picture? I see a side, and I see the matching side. So I see these two sides. They are the corresponding sides. Those are the matching sides. So which one is the small one, 42 or x? Which one is the small one, 42 or x? They give you the length of one of them, and then they give you x. They don't know the length of the other one. Right? 42 is the small one. Very good. So I'm going to put that up top, 42. And then what's the length of the corresponding large one? What's the one that matches that? Well, we don't know that, do we? It's called x. So guess what we're going to put there? We're going to put x. Okay, so the first thing we do to figure this out is we set up our proportion. How do we set up our proportion? Well, we have our scale factor. That's our ratio. And it has to equal the ratio of the other sides. So we know the scale factor is 2/3, and it has to equal the ratio of those corresponding sides. So 42 over x. Is everyone good on this setup? Is everyone good on how I set this up? Because if you're not good on how I set this up, because this is the hardest part, setting this up. Once you set this up, the rest is cake. Hello? Is everyone still asleep from our technical difficulties? Okay, yes. Somebody said yes. Can I see thumbs up? Show me something in the Zoom. Show me a thumbs up or the party or the right. Oh wait, hold on. Where is it? Okay, good. So now once it's set up, the rest is easy. All we got to do now is cross multiply. So this times this, right? The cross products. 42 times 3 equals this times this. 2 times x. Okay. Remember these problems? Remember we did this last week? We had proportion problems like this we were solving. So you spent almost a week solving these kind of problems. So this was easy. So now what's 42 times 3? 126 equals 2x divided by 2 divided by 2. So x equals 126 divided by 2 is 63. So that means this side right here is 63. Okay, I'll give you a second to copy, to ask any questions. That's pretty much it. So all the stuff that we learned about similar polygons, scale factors, corresponding sides, proportions, right? Creating the ratios. All the ratios have to be equal. So if the ratios are equal, there's your proportions. All that comes to here. You just use all that to set up a proportion and solve for the side that is missing. Also, I had a couple of you panicking, sending me messages saying, Mister, I didn't do the homework. I'm sorry. There was like 5 of you sent me a message saying, I'm sorry, I didn't do the homework. I didn't understand all of it. And maybe you didn't hear me yesterday. I changed the due date. And I didn't even assign the classwork. Some of you were even worried about the classwork. I didn't even assign the classwork. So don't stress. Homework is due tomorrow night. Okay? So do some of it tonight. Bring questions tomorrow. I'll answer some of the questions. Like I'll answer that perimeter question tomorrow because I want you to think about it based on what I'm showing you. And if you can't figure it out, I'll show you tomorrow, because the perimeters are still the same proportion. Same ratio, same scale factor. All right, let's try another one. Let's see. Let's get a nice one. Okay, let's look at number 7. Yes, let's look at number 7. I'll give you a minute, because they don't give you the scale factor, but they give you some information here. I'll give you a minute to try this one. Go as far as you can. If you can't solve it, don't worry, go as far as you can. I'll give you a minute and a half. How about that? Two, 1, 0. All right. So some of you were stuck. It's okay if you were stuck like, Mister, I don't even know where to start. Start with what we've done, right? What's the first thing we did here? Remember, we didn't have any numbers or anything, right? Remember these problems we were doing before? There was no side lengths or anything. What's the first thing we did here? We matched up everything. So the first thing you should do, because you're looking here and you're like, Mister, number 4, they gave us the scale factor. Yeah, they were usually, I don't know if you noticed this, usually in math books and math, the first problem is usually they give you a lot of information. And then later on, they give you less and less information, and that's why the problems get a little more difficult, right? Because you got to figure things out. What? I got to figure things out, mister? Oh, come on, man. I got to figure things out. Yes, you got to figure things out. So the first thing you should do is match up. How do you match up? Well, look, they give you a similarity statement here. Here's their similarity statement. It's telling you what is matching. So let's color coordinate. P is first, W second. So P and W match. Q is second, X is second. So those match, Q and X. R is third, Y is third. So R and Y match. Let's pick a third color. S and Z match. So S and Z also match. So you see there? So the first thing you should do, if you're stuck and they give you a similarity statement, you should match up the things. Okay. Now you need to set up a proportion, because if you're going to solve for a side, you have to set up 2 ratios. You have to set up 2 ratios. So the first thing I would do is I would look for sides that have 2 numbers, because I need a ratio. I need a ratio that has 2 numbers. Right? I need this. I only have one spot for a variable. I don't want to have a bunch of variables everywhere. So I need to figure out what that scale factor is. So let's look here. If I look at orange purple is 40. Orange purple is 75 over here. So I have 2 sides here that have numbers. But now I need to decide, am I going small to large or large to small? Well, what order do they do? Large, small. They did large to small, didn't they? So let's do large to small. So I'm going to do orange purple. Orange purple is 75. And then orange purple over here is 40. Okay, so I just made one ratio between 2 sides. I made one ratio where I had 2 numbers. Now let's make the other ratio. The other side's where it has the unknown part. So let's look at the unknown. Where's the unknown? Unknown is right here. That's orange blue. Orange blue. So which one goes first? Large goes first, doesn't it? So X would go first. So that means X goes right here. And then orange blue on the small one goes here. 32. Okay? We went large over small. Why do we do large over small? Because that's the order that the problem gave it to us in. Is everyone clear on what I did? If not, ask now. Because this is the hard part. The rest of this, solving it, yes, it can be, some of you still have trouble solving equations, and that's okay. We can practice that. But at this point, everyone fine on how okay, someone says, can you please repeat this? Okay, let me explain what we did. So the first thing we did was I matched up everything. First, second, third, fourth, and I use colors so you can see everything matched up on the two figures. Next, I needed to set up a proportion, right? Two ratios that equal to each other. Two ratios that equal each other. So what I'm going to do is I'm going to look for two numbers or two sides that have numbers because I want a ratio that has two numbers, right? So I looked here and I looked at, oh, orange, purple, orange, purple. That has 40, that has 75. So the orange, purple, those are matching sides. Both have numbers. But which one goes first? Well, according to this, large goes first, small goes second. So large over small. So orange, purple, that's 75. I put that first. And then orange, purple, the matching side, I put down here, right? Large one, small one. These are the two matching sides, orange, purple. And then now I got to set that equal to, now I'm going to make my ratio that has the part that is missing. So I look at the part that's missing, that's right here. That's orange, blue. So I look at orange, blue over here. Yes, they have a number here too. So which one goes first? Large goes on top. So orange, blue, large is X. That's why I put X there. Orange, blue on the small one is 32. Those are the matching sides, so I do that. Once I've done that, the rest is easy street. The rest is easy street because now I just say this times this, right? Cross products, 40 times X equals 75 times 32. Ooh, numbers are getting bigger now, guys. It's okay. Use your handy dandy calculator. So what is 75 times 32? 75 times 32 in your handy dandy calculator. That's 2,400 equals 40x. Now divide both sides by 40. Divide by 40. X equals, use your handy dandy calculator. You get x equals 60. So this side equals 60. Make sense? Mister? Yeah. This seems too easy. Are they always going to stay this easy? Well, Timmy, no, they're not going to stay this easy. We're starting with the easy ones so you get the hang of it. Then we're going to throw in some extra ones where you're going to have to figure something else out, right? But it's not going to get, it's not going to get too much harder. It's not going to get too much harder. This is still the same thing. The steps we did here are going to be the same steps we do for the other ones, okay? You set up two ratios that are equal to each other. Look at the order that the problem gives it to you in. That's how you're going to make your ratios. Find a ratio of matching sides, equal it to a ratio of the other matching sides, and then solve. Okay, so I'll give you a minute to copy this and ask any questions. Please ask questions. I'm begging you. I am begging you. If you are confused, you need to ask questions. All right, we're going to do one more, and then we'll end class. And then tomorrow you will practice this. You doing the classwork, and we'll do what we did before. I'll open up some breakout rooms, and you can go there and work with other people if you want to, or you can stay here in the main room with me and ask me questions as you're working, or talk to the other people that are in the main room. Whatever works for you. All right, I'll keep this up for 10 more seconds. 5, 4, 3, 2, 1. The homework is due tomorrow night. Yes, I gave you an extra day. I want to make it due after we do the classwork. And I was thinking we were going to start the classwork today and then finish tomorrow, but because of the technical difficulties, we can't start today, which is okay. It's okay. All right, how about this one? See how it's the same steps. You still get a similarity statement, right? You still get a similarity statement. But if you notice, these sides now are binomials, what we call binomials. And the classwork, yes. Classwork is we're going to start tomorrow. We have binomials. We don't just have an x by itself. We have x plus 6. Now we have x in two different places too now. We don't just have an x in one spot. We have an x in two different places. Does that mean our steps change? Nope, they do not change. We still do the same thing. I'm still going to say A and K match. So A and K match. G and X match. G and X. I'm still going to use my colors. Orange, M and D match. M and D match. Okay? And if we look here, which one's the smaller one? Well, this one looks like the smaller one. They're kind of close, right? This is small. This is large. And so they are going from large to small. So that means my ratios are going to be large over small. Okay, so now it doesn't matter which one I pick because I don't have two numbers. So let's see what we're going to do. Let's just pick a side. How about green, orange? Green, orange. And we're going to put large first. So we're going to do green, orange, which is 36. I'll do that one first. 36. And which one does that match up with? Well, let's do green, orange on the other one. Green, orange on the small, which is X plus 6. And that equals, let's see, what's the other side? Purple, green. Purple, green. So we'll do purple, green on the large, which is 32. And then purple, green on the small, which is X plus 3. Okay, same setup, same steps. I color code my things that are matching so that way I can easily make my ratios. Make my first ratio. Remember, we're going from large to small. So I choose green, orange for my first ratio. So green, orange will be my first ratio, so 36 on top. Right. And then X plus 6 in the bottom because that's green, orange for the small one. Then I set that equal to, let's pick another side. I picked purple, green. So I do the large first, which is 32. Large goes on top, right? Large goes on top. And then purple, green on the bottom, which is X plus 3. So if you're good on the setup, if you're okay with the way we just set this up, if you understand that because the colors help you and you just put, all you're doing is making a ratio of matching sides. This ratio is matching sides. That's all this is. That's all it is, a ratio of matching sides. And we're putting the large and the small, large on top, small on the bottom. And so now I just cross multiply. Same thing. I still just cross multiply. This times this. So remember, we put that in a group, right? When we have two things in a denominator or a numerator, we put it in a group. So 32 times that group, X plus 6, equals 36 times that group, X plus 3. All right, everyone good so far? So I'm going to put it right here. 32 times the group X plus 6 equals 36 times the group X plus 3. Okay. Now the rest is just, the calculator would do most of the work. Your handy dandy calculator. So now let's distribute. 32 times X is 32X. 32 times 6, so that's plus 32 times 6 is 32 times 6 is 192. Equals 36 times X is 36X. And 36 times 3 is 108. Okay. So now I have X on two sides. I don't like X on two sides. So what I'm going to do is I'm going to subtract the smaller one. So subtract 32X on both sides. And that's gone, which is right. I want to get rid of one of them because I don't want to have X on two different sides. So I have 192 equals 4X plus 108. Then I'm going to subtract 108 from each side. And I'm going to get 4X equals, what's 192 minus 108? 84. And if I divide by 4, X equals 21. X equals what?
21.
Okay, thank you. Thank you. So X equals 21. Now, we are not finished because 20, oh, okay, yes, we are. What does it say? Find the value of X. So we're done. So we are done. If it said find the value of the sides, I'd have to put 21. I'd have to put
21
right here. And this side would be 27. And I'd have to put 21 right here, and this side would be 24. Okay, but that's not what it asked for. So always look at the question, see what it's asking for. Once you find the variable, look at the question and see if it's asking for. Is it asking for x, or is it asking for the side? If it was asking for the side, I'd have to put the x in here to find the side. I'd have to put the x in here to find the side. Does that make sense? Okay. So that's it. We are going to practice this tomorrow. That's how you find side lengths using proportions of similar triangles. If you have any questions, let me know now, or you can send me on Schoology. It is 9:50, so class is over. I don't want to keep you and make you late to your next class. So everyone take care and have a great day.